And now for a little hint on the last problem on the solving non-right triangles worksheet. I'm not going to do the problem entirely here, but I'm going to give you enough to get started. This one's a little different, of course, in that we don't have any angles to get started. So we're still going to use the same strategy in dropping an altitude. And it doesn't really matter which vertex you decide to drop it from. But this time, instead of trying to jump in and use SOHCAHTOA, we're going to approach this a little differently. So this altitude splits this 9 side up into 2 pieces. One side we'll call x, and the other side would be 9 minus x, because it's the whole side minus the first thing. So instead of using SOHCAHTOA stuff, since we have no angles whatsoever and we don't know enough sides in the right triangles to actually get the SOHCAHTOA, we're going to set up Pythagorean theorem. So for the left-hand side, we're going to call that altitude we dropped h. For the left-hand triangle, that would be x squared plus h squared equals 11 squared. And on the right-hand triangle, that would be 9 minus x squared plus h squared equals 13 squared. Now, what we have here are 2 equations, each of which have h and x in it. So here's my hint for you. We're going to take the Pythagorean theorem for each of these, and we're going to get h squared by itself And then since both of these things are equal to h squared, we're going to set them equal to each other and then solve for the x. Now I'm going to leave the rest of that for you, but just know that once you get this x here, you then know this side, and now you have enough information to start getting angles in each of the right triangles.